we have now seen two examples how Aristarch uses phenomena in the universe to get information that he was not able to measure in a traditional way. And the half moon gave him the possibility to find the distance between moon and earth compared to earth and sun. And the solar eclipse gave him the possibility to find the radius of the moon compared to the radius to the sun. And those are examples how human beings started to think in a trigonometric way. Let's just take a little bit about that. Until then, humans thought in geometric ways. What does that mean? Geo is a word for earth. Geometric is about measuring the earth. And actually the ancient Egypts were very good at that. When the Nile go over its borders, they were really good in measuring where should the fields be established again so that everybody could have their field back. This is a question about measuring the earth, geometry. Now we are going into trigonometry. And here we are not measuring anymore the earth, but we are measuring with triangles. And I have shown you how Aristarch did that. But he continues, and the next phenomena he looks upon is the lunar eclipse. And I ask the students, lunar eclipse, what is this about? And they say it is something that occurs when the moon goes into the shadow of the earth. So we just draw a picture of that at the blackboard. So as you see, it's always difficult to get things very accurate at the blackboard, and the students get respect for that because they also do construct on the blackboard themselves. And I say to them, of course, you should have a construction in your book which is even much more precise than what I'm able to get at the blackboard. But never mind. This is the sun, this is the earth. We just write that. This is the sun, and this is the earth. So, and this is the shadow of the earth. And what is lunar eclipse? Lunar eclipse, what is this about? It is about the moon passing into the shadow of the earth, disappearing and passing out again. So I ask the students, what happens from now to now? And they say, well, the moon does disappear. It goes from just starting to disappearing, and now it is completely disappeared. This is, in a way, our period 1. The moon disappears. And then I ask them, okay, what happens now from here to here? And they say, the moon is hidden in the shadow. So from here to here we can say it was P1, it is the moon disappears. From here to here it is P2, the period 2, the moon is hidden. And what does happen now, I ask? Well, you can see the moon again. In P3, the moon comes back. And then I ask them, well, can you say anything about how long those periods actually take? And they conclude, well, P1, that the moon does disappear, must be the same time, the same length as period 3 that the moon comes back. Okay, we agree on that. And then I tell them that Aristarch actually did measure all those P1, P2 and P3 periods, and he did find out that not only P1 was equal to P3, but also P2 actually was equal to the two others. And then we must think about what does that mean for our construction. Well, it actually means that the moon passing from here to here, it is, you can say, 2 moon diameters. This is what P1 takes. And when P2 is equal to P1, that actually means that here, when the moon is in the shadow of the Earth, it goes the same distance as it does in P1. So I asked them, how can we then make a better drawing? And they say, well, you actually need to draw then the moon like this. This would be the right way of making your drawing. And we conclude, okay, then we will do that. And this we will use now for finding more information about the distances in the universe. And I say then, well, maybe you will find a smart way how to put similar triangles into this so that we can say anything about new distances. And we agree, well, what do we have here? Here we have the radius of the sun, and here we have the radius of the Earth. Okay. Then we could just make a triangle like this. Sometimes you see students get this idea. Sometimes you must help them a little bit. We will just do it a little bit more accurate. Those two should be parallel. And I asked them, okay, what can we say now? This distance must be 2 radius from the moon. This is 2 radius of the moon, and this must also be here and also here. Okay, that means this piece, how much is that? Well, this is radius of the Earth, and you take away 2 times radius of the moon. So this piece here must be radius of the Earth minus 2 radius of the moon. What about here then? Well, the whole radius of the sun, actually we knew from here, it is the same as 19 radius of the moon. And when this is 2 radius of the moon, this part here that I will make violet, this one is radius of the sun minus 2 radius of the moon. Okay, what more do we know? Well, we know this distance. Well, we know this distance is 1 moon-Earth distance. And what more do we know? We know this distance is 1 Sun-Earth distance. It is the same as 19 Moon-Earth distances. So what do we know now? Now we know this distance is 20 Moon-Earth distances. What does that mean? That means we have 2 similar 3 angles. And we know that the ratio between those 3 angles is 20. So now we can put an equation, because now we can say that if you take 20 times this piece, then you will get 17 times the radius of the moon. Okay, we just calculate. And we get our first result. The radius of the moon, of the Earth, is 57/20th the radius of the moon. It will be almost 3 times.